to do the little r, it's the gap. It's the distance between the x-axis, I mean the y-axis and the inner curve. So the inner curve, the leftmost, that r is now going to be f of y minus 0. That's little r. And once again, I'm doing minus 0 because what's going to happen on Thursday, that's not going to be 0 anymore. So if we write the volume for this, since this is revolving around the y-axis, that tells me right there it's with respect to y, right? Everything's with respect to y. What are my limits of integration? They're now from, this is going to be, we're going to call this c, and we're going to say this distance right here is d. So we're stacking washers this way. Let's draw a cross section real fast. So this is my little inner r, and that's going to be an inner hole. And then I have an outer r, and that's going to be my outer surface. That height there is change in y. So my hole also has a thickness of y. So you'll see the washer. We're going to stack all these washers. And when you draw the sketch of this, so it's going to do like this on the outer surface, right? That's the big R. And the inner surface is a tornado. Like that. It's a tulip vase. And the volume is going to equal, factor out the pi. It's the integral from c to d, because I'm doing, these are y values. And the outer surface is based on g, so it's g of y squared minus f of y squared dy. So I'm doing right minus left, just to emphasize. This is the right, this is the left. The big radius is going to be the rightmost curve. The little radius is going to be for the leftmost curve. And then to get the radius, you're going to do the curve minus the axis of rotation. For right now, that's going to be 0. It's going to get better. What the heck does a problem look like? Well, funny you should ask. Does that look like kind of like my favorite two curves? Yes, it does. So let's do my favorite two curves. And to make this fast, I'm not going to give you the words. I'm going to show you how to do it. Okay, we're just going to show you, and then we'll get to the words later on your worksheet. So really fast sketching. We are sketching my favorite two curves, square root of x and x squared. Do we have to get it perfect? No. So square root of x. So this is f of x equals square root of x, and g of x equals x squared. Their point of intersection is 0 and 1. 0 and 1 either way. Yes? For this one, we're going to rotate the region between f of x and g of x around the x-axis. So what's it with respect to? As soon as you see this, it's with respect to x. I left out a finesse to x. All right, so we're going to rotate around. So we have to have an inner radius. That's my inner radius. Do you see that there's a gap? Do you see that the function, whatever region we're talking about, does not touch the axis of rotation everywhere, so there's a hole? Then this is my outer radius. So my outer radius is equal to f of x, which is the square root of x minus 0, which is square root of x. My inner radius is equal to x squared minus 0, which is equal to x squared. My limits of integration are an x of 0 to an x of 1. And we got 22 seconds left. So my volume equals the pi integral from 0 to 1 of the outer radius, which is square root of x squared minus the inner radius, which is x squared, squared dx. Boy, I got that in. And we'll let the time go.